Hi guys, this week we're going to continue the unit circle lesson. So if you haven't watched the last video, I recommend pausing this one, going back and watching that one, and then come back and watch this one. So last time we went over the special right triangles and the relationships between the sides that arise from those triangles. And this time we're going to work on putting those triangles into the unit circle so that we can work with sine and cosine. So here we go. Okay, so last time we talked about special right triangles, specifically 30, 60, 90 triangles and 45, 45, 90 triangles. And we looked at how if the hypotenuse equals 1, we can find the length of each of the legs using a little bit of algebra. Now I want to look at a little circle, and we draw this circle on the xy plane. So we have here an x-axis and a y-axis, and we've drawn a circle so that its center is at the origin, and the radius of this circle is exactly 1. So if we go in the positive x direction, we get to the point 1, 0 when we cross the circle. And in the y direction, we get to the point 0, 1. In the negative x, we get -1, 0. And in the negative y, we get 1, -1. Another thing that we notice is that if we draw a line, or a ray, really, from the origin in any direction, we will cross the circle at exactly this particular point on this ray, and the length of the segment that's created is also going to be exactly 1, because we've made a circle whose radius is 1, and this creates a radius. And from this line segment, if we wanted to, we could drop a vertical segment that goes directly down to the x-axis. We create a right angle here, and now we have a triangle. And we know that the hypotenuse of this triangle equals 1. And so if we know this angle, we can now find the vertical leg and the horizontal leg. And that's the basis of what we're going to do with the unit circle. So we're going to look at the specific triangles that we worked with the other day, and we're going to apply them to this circle using this method. So we're going to look specifically at the 3 triangles we worked with. We had a 30-degree triangle, and when we were working with this 30-degree triangle, I'm now referring to it as a 30-degree triangle and not as a 30, 60, 90. Because remember, we were talking about angle A and how that's the only one that matters. The only angle that matters right now is the one that's formed between the x-axis and our segment. So the 30-degree triangle, the pink triangle, we discovered that the horizontal distance is going to be this right here. And we discovered that that was radical 3 over 2. And we also discovered that this vertical distance was exactly 1/2. And that's all based on the fact that this hypotenuse here, this segment, equals exactly 1. So knowing that, we can say that the coordinate of this point right here, the x is radical 3 over 2, and the y is 1/2. And if we think about what sine and cosine actually mean, sine and cosine are a relationship between two sides of a triangle. The sine of this angle, which is 30 degrees, is going to be the relationship between the opposite side to the hypotenuse. 1/2, well, anything over 1 is just itself, so 1/2 over 1 is 1/2, which means that the sine of 30, using this little triangle where we've conveniently chosen to make the hypotenuse 1, the sine is just going to be 1/2, and that's the y value. And if we think about sine as the vertical distance, when we have a unit circle, we can always say that the y value is going to be our sine value. And then similarly, we can say for cosine, the adjacent side to the 30 is this side right here, radical 3 over 2, conveniently divided by the hypotenuse, which is 1, is just radical 3 over 2. And so our x value, specifically in the unit circle, is going to be our cosine. So the rule is that in the unit circle specifically, your x is going to be cosine theta and your y is going to be sine theta. And that's what makes the unit circle so useful, because we've conveniently chosen to make the hypotenuse 1, to make the radius of the circle 1, so that now we get our sine and our cosine as the coordinates, specifically cosine and sine in that order, as the coordinates of the point that's created on the circle. Let's continue looking at these triangles. If we look at this point right here, in our 45-degree triangle, we found that the x and the y were both equal to radical 2 over 2. So our coordinates for those are the same. And for our 60-degree triangle, we found that, well, it's the same as the other one except flipped, right? Now the x direction equals 1/2, and the y direction is radical 3 over 2. So now we have our nice little triangles, and they have given us coordinates. And we also found, this was from the original circle, that just by knowing the fact that we've gone exactly 1 unit in x and we haven't gone anywhere in y, when the angle is exactly 0 degrees, our x value is 1 and our y value is 0. Now that we know that that corresponds to cosine and sine, we can say that the cosine of 0 degrees is 1 and the sine of 0 degrees is 0. And similarly, when we go exactly up, we find that our coordinates are 0, 1, so the cosine of 90 degrees is 0 and the sine of 90 degrees is 1. Now here's the part where a lot of people get tripped up, is trying to now take everything that we've done here in the first quadrant and translate it to the other quadrants. Now a lot of times people learn all these crazy formulas, well, subtract from 180, and then it's negative, and then it's positive, and all that gets very confusing. I don't like to think of it that way. I prefer to think of it as just fun little reflections over the x and y axis. So let's look at the circle. Don't get overwhelmed by all the lines here. It's just reflections of this first quadrant into all the other quadrants. Just mirror images. So if we take this 60 degrees right here and we say, okay, now our triangle is always formed against the horizontal. So we always have a triangle that's being formed a certain number of degrees away from the x-axis. So for this blue triangle right here, we have 60 degrees right here. This angle is 60 degrees. Okay, well, we're 60 degrees away from this right here, which is 180. So that means that this angle coming from the 0 degree mark was 120 degrees. So when we have 120 degrees, we can now say, all right, well, the triangle that's formed is a 60-degree triangle. And we know with our 60-degree triangle that we have an x value of 1/2 and a y value of radical 3 over 2. But, and here's the important part, we have to remember that now we're in the second quadrant. And in the second quadrant, we've now gone in the negative x direction, right? This little segment here is negative, so we have negative 1/2, and we're still going up in y, so we're still in the positive y, so our y coordinate stays positive. And other than that, we always just want to think about how far away we are from the x-axis. So this little purple triangle here is 45 degrees away from the x-axis, which means that we've now rotated from 0 135 degrees. And the way I thought of that is that, well, if this would be 180 and I'm 45 away from it, well, then that must mean that this was 135. 180 minus 45 is 135. And I didn't subtract that because some formula told me to. I just thought of it as the fact that this straight line from here all the way around to here would have been a straight line, and a straight line has 180 degrees. But I want to be 45 degrees off of that to be right here. This angle right here. So 45 degrees off of the 180, I haven't gotten the full 180 yet, so I have to subtract 45 from it to get 135. So when I have the angle 135, I'm in the second quadrant. Our x, we decided, is negative, and our y is positive, and we just look at this reference point right here, and we say, okay, well, in that case, my x is negative, my y is positive, I have my cosine and my sine for the angle 135. And then, similarly, we do the same thing for the pink triangle. If this right here is 30 degrees, and the straight line would have been 180, then that means this must be 150 degrees. So for 150 degrees, I can find my cosine and my sine by saying, well, the x is negative and the y is positive. And again, I'm just referring to what I did in the first quadrant. Let's continue filling this out. If I continue to rotate, now I'm 30 degrees away from the 180, but now I've gone past it, so I'm at 210 degrees. And now I'm in the third quadrant, which means that x and y are both negative. So I take my x and my y values, and I make them both negative. And we do the same thing for all of our values. And I think you can guess the pattern now. When we get into the fourth quadrant, this right here, this vertical green line, is the 270 degree mark. We have our cosine and our sine for 270 degrees. If we go past 270, we think about the fact that if we were to go all the way around the circle, back where we started, that's 360 degrees. If we're 60 degrees off of the 360, that means that we're at the 300 degree mark right here. So this angle, starting from 0, going all the way around and stopping at this line segment right here, is 300 degrees. Our x now is positive because we're heading to the right, and our y is negative because we're heading down. So our positive x, negative y. And then we do the same for each triangle. And we have filled in our whole unit circle, which acts as a wonderful reference for any special angles that we have, 30, 45, 60, and any multiple of 90, and also 0. So the unit circle is a really useful tool to quickly come up with sines and cosines and eventually tangents, which we won't get into now, for all these special angles. And you won't have to use calculators. A lot of times they don't let you use a calculator for these kinds of things because they expect you to know the unit circle. One last thing that we didn't get into is that the unit circle is often thought of in radians, and there is a reason for that as far as the definition of a radian and how it helps you with things being in the same unit. So we didn't work with radians right now, but I think in our next video we'll probably talk about a radian and what it means and how we can convert between degrees and radians. So I hope that this helped clarify the unit circle. It's not a big mystery. It's just a lot of work. It's meticulous, but if you focus on it, you can definitely understand it. Take care.